Ngayong gabi na ang reporters karon.
Ngayong gabi, sir. Magpasulod pa sila, sir.
Sige, nato na nato.
Sige, sir.
Good evening, sir. Pwede na mag-start, sir?
Pila ka reporters mag-report karon?
Tulo na lang, sir.
Tulo na lang. Sige, pag-start na. Na naman ka sila.
So, hello everyone. We are the last group, so we are going to continue the remaining topic that we tackled last week. So, I hope you will listen.
Design example. This figure is the layout of locations of convenience receptacles and other outlets for design example. This is an example of a system design of a single family residence, single story that is 61 feet, 6 inches by 36 feet. This residence contains general lighting, lights and receptacle outlets, equipment and appliances, contains the following: water heater 3800 VA, clothes dryer 4400 VA, dishwasher 1000 VA, range 11700 VA, waste disposal 1000 VA, air conditioner 6300 VA, and garage door opener 1000 VA.
Hello everyone. So, I am here to discuss about circuit design. What is circuit design? Circuit designing is the systematic selection of electrical and electronic components that, when connected together, as described in the design schematic for some useful, defined purpose based on a defined set of output and input devices. So, these are the several areas that we need to bear in mind when designing electronic circuits and equipment. Number one, locate the convenience receptacles. So, as you can see in the bottom, mo ni ang atong symbol sa receptacle. First thing we need to do is locating it in the floor plan with the exact symbols representation. Receptacles should be located conveniently following the guidelines provided as mentioned last week ni Mr. Econar. GFCI and AFCI protected receptacles should be located following the requirements specified. Switching sizing of conductors and circuits layout will be done later. can see in the floor plan, mao ni ang atong mga receptacles or outlet. 2. Locate all appliance and equipment outlets on the floor plan. First thing, we need to remember that this process calls for coordination with the architectural designer because each appliance and piece of equipment must be known to locate the outlets properly. The electrical designer should request that the architectural designer list all appliances and equipment in writing or on drawing for complete coordination. The electrical designer should also check the number of appliances or equipment required. The electrical designer will need to know the specified voltage and amperage different manufacturers. Kanina floor plan, ginalocate nato ang appliances. So we have clothes dryer, clothes washer, and exhaust fan, and etc. Number 3, lighting layout. Locate the locate the lighting fixtures using the appropriate symbols to represent each. So mo ni atong symbol sa suga. The electrical designer should make a list of type luminaires and the load requirements. This list will use later when grouping circuits. It may also be included in the specification or on drawings as luminaire light fixture schedule. So as you can see in the floor plan, kaning mga lingin mao ni atong mga suga. So mao ni ang atong luminaire light fixture schedule. So we have fixture designation, fixture type, lamp type, mounting. So number 4, switching layout. Layout the switches required to control the lights, appliances, equipment, and any desired receptacles. So mo ni atong symbol sa switches. You can see in the floor plan. For example, we have here in the dining room, kaning S, mo ni ang switch for dining room. Number 5, locate the panel board in convenient location. The location must be accessible. As you can see in the floor plan, atong panel board located just sa garage. So, if ever man ay emergency, dali ra siya ma-access. Number 6, circuit layout and numbering large appliances and equipment. Layout circuiting for large appliances and equipment served by individual branch circuit. So, as you can see in the symbol, mo ni atong conduit, mo ni ay ang symbol. You can see in the floor plan, kaning lines na connected sa outlet, switch ug suga, mo ni atong ginatawag na conduit. So, as mentioned pod ganiya katong individual branch circuit, ang mga large appliances like clothes dryer, clothes washer, mo na siya ang nabilong sa individual branch circuit. Number 7, circuit layout and numbering lighting and convenience receptacles. First, circuiting for lighting convenience receptacles and general purpose lighting branch circuits. Usually 15 ampere and 20 ampere general purpose branch circuits are used for convenience receptacles, luminaires, and small appliances. A good designer tends to be little more conservative, generally limiting a 15 ampere branch circuit to 1000 to 1200 volts ampere and a 20 ampere branch circuit to 1300 up to 1600 volts ampere. Such as layout allows for extension of a circuit if it is necessary to add a light or a convenience receptacle instead of adding a whole new circuit from the panel board. So katong mga less load like receptacles, lights, and etc. mo to siyang nabilong sa branch circuit. Then kani pong numbering like C5, 7, C1, 3, ang purpose ani niya kay para ni siya sa panel board. Then kani pong isa ka arrow, ang meaning ani is one circuit ra siya. Then kani pong duha ka arrow, mo na siya ang two circuits. So number 8, layout the panel circuits. In large designs with more than one panel, this provides the electrician with a schedule of what circuits will be served from what box. So nato dire pole panel board layout. So napud tay circuit number based on my own understanding, mag-base ni siya sa electrical designer. Since duplicated atong appliances sa example, and pag number niya, yung gi-alternate, mag-base siya sa pinadako nga load and breaker. So, napod tayo wiring layout, mo na kining number 10, number 12, and number 5, AWG, mo na atong kabaga sa wire. So, kaning spare, mo na to ang mga extra nga pwede tauran ug mga appliances. So kaning panel board dili na siya permi ginagamit sa mga residential, mostly ginagamit ni siya for commercial projects para mag-guide ang electrician and designer. Thank you for listening and let's move to the next reporter.
Good evening, everyone. I am Maria Cristina Zipar presenting the topic load computations. Load computations involve computing the demand load for a building system or a distribution system extending from a panel board. This load includes the total of all general lighting, appliance, and equipment loads in the building. The demand load allowed by the National Electrical Code takes into account that all of the electrical connections will not be in use at one time. As a result, the demand load is not a total of all connected loads, but rather a fraction of connected loads. So unsa man ang connected load and demand load? Connected load is the energy consumed when all connected systems, circuits, components, devices, or equipment are operating and drawing power at the same time, while operating demand load presents a more realistic total of energy consumed or drawn. So that's why fraction ra siya sa connected load because according sa code, tanan electrical connections kay dili dapat gamiton at one time. Code prescribes methods of computing the demand load, which trims down the total connected load to a safe, more reasonable level. Shown on the right is the demand load computations and panel board layout worksheets that assist the designer in these computations. Now let us tackle the general considerations in demand load computations. First, compute the general lighting load. This is calculated for all types of occupancies based on the unit load given in the table times the square footage of building. For this exercise, it is based upon code specified 3 VA per square foot for residences. Shown in the right is a picture of lighting load for specified occupancies according to National Electrical Code, Chapter 2, Article 220. There we can see that for dwellings, the specified unit load is 3 volts ampere per square foot or 33 volts ampere per square meter. The floor area is determined using the outside dimensions of the building involved and number of stories. For dwellings, do not include any open porches, garage, or carports. Any unfinished or unused spaces do not have to be included in the square footage unless they are adaptable for future use. This is under Article 220.12. For the hypothetical residential system example, the outside dimensions, excluding garage, of the building are 61 feet 6 inch times 36 feet. There are 2 to 14 feet square foot of floor area. The minimum general lighting load based on the specified 3 VA per square foot for residences, 3 VA per square foot times 2 to 14 square foot is equal to 6642 VA. So this 6642 VA is the minimum general lighting load. Second, compute the appliance and laundry circuit load. The code requires at least two 20A appliance branch circuits for the kitchen. The load is based on 1,500 VA for each appliance branch circuit in the kitchen. So makita sa right figure nato kung asa ni siya gi-base which is sa Article 220.11 C1 and 2. In addition, one 20A circuit is required for laundry room appliances. For the residential system example, there are three 20A branch circuits for appliances. So 3 circuits times 1,500 VA is equal to 4,500 VA. So mo na siya ang appliance and laundry load. Third, subtotal the general lighting, appliance, and laundry branch circuit loads. For the residential system example, ang general lighting nga atong gi-compute kanina, which is 6642 VA, plus appliance and laundry circuit nga 4,500 VA. So ang subtotal is 11,142 VA. So that is the subtotal sa general lighting, appliance, and laundry branch circuit loads. Fourth, electrical connections will not be in use at one time. To prevent hazard arising from the use of electricity, the demand load allowed by the code takes into account that all of the electrical connections will not be in use at one time. Let us look at the graph on the right. So this is from Article 220.42. Makita nato ang demand load for each type of occupancies. In a dwelling, the first 3,000 VA are taken as 100%. And from 3,001 to 120,000 VA, only 35% of the load is calculated. For this residential system example, the subtotal is 11,142 VA. So, ang first 3,000 VA niya ang demand factor is at 100%. Then the rest will be 35%. So, pila na bilin? 11,143 minus 3,000 is equal to 8,142 VA. Then, 8,142 VA at 35% is 2,850 VA. Then, i-add na to ang 3,000 VA plus 2,850 VA. Ang atong total demand load is 5,850 VA. So, that is the total demand load. The load of all the other appliances and equipment must be added to this demand load to determine the total service load on the system. So this will lead us to the fifth general consideration. Fifth, to determine the appliance and equipment load, all appliances and equipment that will not be on the lines discussed above must be listed along with their electrical requirements. Although typical ratings are given in tables 19.12 through 19.16, nameplate ratings from manufacturers' data should be used in the design. For the residential system example, the following is a list of fixed appliances and equipment and their ratings from manufacturers' data. Water heater 3,800 VA, clothes dryer 4,400 VA, dishwasher 1,000 VA, range 11,700 VA, waste disposal 1,000 VA, air conditioner 6,300 VA, and the garage door opener 1,000 VA. The demand load for an electric range consisting of an oven and cooktop unit is taken from manufacturer's data. For the residential system example, mag-base ta sa table 220.55 para mahibala nato pila ang demand load sa electric range. So for one appliance with a rating of 11.7 kilowatt, which is not over 12 kilowatt, the demand load would be 8 kilowatt, which is equal to 8,000 VA. So our electric range demand load is 8,000 VA. The demand load for the clothes dryer is the total amount of power required according to the manufacturer's data. Based on the table 220.54, the demand load factor for the house electric clothes dryer that has 1 to 4 in quantity will have 100% demand factor. Since the example residential system only have one clothes dryer, then the full 4,400 VA must be used in the calculation. So ang atong clothes dryer demand load is 4,400 VA. The demand load for the fixed appliances other than the range clothes dryer, and air conditioning and space heating equipment is taken as 100% of the total amount required, except that when there are four or more of these fixed appliances, other than those omitted, the demand load can be taken as 75% of the fixed appliance load. For the residential system example, there are three fixed appliances: the water heater at 3,800 VA, the dishwasher at 1,000 VA, and the waste disposal at 1,000 VA. The total of the ratings is 5,800 VA, also the demand load. So 3,800 VA plus 1,000 VA plus 1,000 VA is equal to 5,800 VA. So the fixed appliance demand load is 5,800 VA. Motors, such as those used in central air conditioners, have their demand load calculated as 1 to 5 of the motor rating. According to NEC, 1 to 5% of the full load current rating of the highest rated motor. So, for the residential system example, the air conditioner is rated at 6,300 VA and the garage door opener is at 1,000 VA. So, i-add ang duha, 6,300 VA plus 1,000 VA is equal to 7,300 VA. To calculate the demand load, i-multiply nato ang 7,300 VA sa 125, which is the demand load sa motors. So the total demand load here is 9,125 VA. Then the total demand load for all the lighting and appliances is then tabulated. For the residential system example, general lighting, appliance and laundry, 5,850 VA, electric range, 8,000 VA, clothes dryer, 4,400 VA, 4,400 VA, fixed appliances, 5,800 VA, motor, 9,125 VA, then we will come up to the total demand load, which is 33,175 VA. So that is how you compute the total demand load.
Service entrance design. The service entrance conductors and equipment are designed based on the computed total demand load. Number 1. The minimum service entrance size is found by dividing the demand load for the building by the voltage serving the building. Most commonly, 240 V service is used. Example, the total demand load of 33,175 VA is divided by the 240 V service for a minimum service entrance of 143A. Minimum service entrance equals 33,175 VA over 240 V equals 138.2A. The 138A computed demand load would be rounded up to the nearest commercially available panel board rating. A panel board with a 150A rating would be selected. A 200A panel board would be a better choice if expansion for additional future circuits for appliances and other equipment was anticipated. Assume a 150A panel is deemed adequate. Number 2. Sizing the service entrance conductors and any conductors between the service equipment and the branch overcurrent device, circuit breaker, or fuse. The feeder size is based on the computed demand load. Example, using XHHW 75 degrees Celsius, 167 degree Fahrenheit aluminum service entrance conductors and the 150A load as calculated. 150A feeder demand load 3/0 AWG XHHW aluminum. Number 3. The size of the neutral conductor may be determined as 70% of the demand load calculated for range plus all other demand loads on the system. Example, the neutral feeder demand load would be range load 8,000 W times 70% equals 5,600 VA. All other demand loads equals 25,175 VA. Neutral demand load 30,778 VA. Neutral net computed demand load equals 30,778 VA divided by 240 V equals 128.2 A. Select the size of the neutral conductor for a 128A neutral feeder demand load. 2/0 AWG XHHW aluminum conductor. Example, the three service conductors are 2 number 3/0 AWG and 1 2/0 AWG aluminum conductors. Circuit design. Circuit design involves ascertaining the number and rating of circuits needed in the panel board. It generally involves the following steps. Number 1. Determine the minimum number of lighting circuits by dividing the general lighting load by the voltage, finding the amperage required and dividing the amperage into circuits. Example, the general lighting load was calculated above as 6,642 VA and the voltage used for the lighting is 120 V. Therefore, 6,642 VA divided by 120 V equals 56A. Because the general purpose branch circuit size is limited to 80% of the rating, 420A branch circuits for a total of 64A or 515A branches for a total of 60A are needed. For 20A circuits, 56A over 20A times 80% equals 3.5 equals 4 circuits. For 15A circuits, 56A over 15A times 80% equals 4.7 equals 5 circuits. This is the minimum number of branch circuits required to serve the residents. In laying out the circuits, almost all designs will have more circuits than the minimum number required. This is because most designers will limit each circuit to fewer receptacles, lights, or a combination of receptacles and lights. Number 2. Lay out and number all branch circuits on the drawing. Bear in mind that, in most cases, all of these general use receptacles and all lighting will use 120V service. In large commercial applications, 277V may be used for interior lighting. Note that each circuit is numbered. Example, there are a total of 14 circuits.
For the last topic of our report, the panel board selection. Select the panel board based on the number of circuits and the required amperage. Be certain that all the pole space is not taken up so there is room for expansion. Keep in mind that each 120-volt circuit takes up 1 pole for a 1-pole circuit breaker, while each 240 volts or 120 per 240-volt circuit takes up 2 poles. For the residential system example, it has 14 120-volt circuits. It is said that each 120 volt takes up 1 pole, therefore, in this example, there is 14 poles. Then there is 4 240 volt circuits. It is said that each 240 volts takes up 2 poles, so 240 volts times 2 poles is equal to 8 poles. We will add the 2, 14 poles plus 8 poles is equal to 22 poles. This is the total poles required. To select the panel board, we'll keep in mind how many poles are required and there should be room for expansion. So the panel board that should be selected has more than 22 poles.
Then we also keep in mind the panel board rating that was selected. So the total poles required is 22 poles, then the panel board rating is 150 ampere. We'll look at the table 18.4 since the panel board rating is 150A. Then we will use the 150 ampere 24 pole panel board. So that is all for our report. Thank you for listening.
Human na. Hmm?
So that would be all for our topic. Thank you for listening.
Sige, thank you sa inyong mga report karong gabi. So, naba tayong mga questions sa mga reporters kay ang last topic na ba sa report no is mo ni ang guide ninyo for your project. So, kung namoy mga questions sa ilaha, mas maayo makapangutanan na mudaan. Wala.
Wala atay question, sir. If ever naaman, i-contact na lang through messenger.
Okay, kadali lang ha. Saan man to? So, nakoy ihatag nga quiz sa inyo ha. So first, diri sa ta sa quiz number 3. So sa quiz number 3 ninyo is consist siya of mga 4 items. Then na ay sub-items each number no. So simple ang instructions, ikuan lang gyapon siya. I-handwritten ni ha. Then tapos i-upload ninyo ning file ninyo as PDF dito sa UStep. Ang file name is quiz3 then underscore last name and section. You may answer directly. As for the exemption, all Chapter 19 reporters are exempted sa aning quiz. So, despite nga exempted ta, please submit a file na nag-indicate na exempted mo aning quiz. So, pila man ni ka groups ang exempted ani? I think mga 6 groups man yata ni. I think bas kabalo naman mo kung naka-report mo Chapter 19, di ba? So, by the way, no? So, aside sa pagpasag file sa mga reporters, kung malate, ayaw taon mo o late og submission aning file ninyo. Maski reporters mo and exempted mo, ayaw mo kalate palihog lang. Og malate man galit ta, passing grade ra kung ihatag sa inyo ha. So, example, 30 man no. So, akong atag sa inyo ha ani, nara sa 21. So, gansi kay mo. Reporter mo pero gamayin yung kuha na ang uban nga nag-report na kadako pas inyo. So, bato, be on time na lang sa submission. Ako na siyang i-post dito sa step then dito ra ninyo kaon ang file. So, dapat tay questions ani so far? I guess wala na no. So,
Sir, kamusta ang deadline sa quiz number 3?
salamat kiki sa pag-remind. Ang deadline sa quiz number 3 is tomorrow tomorrow 9 p.m.
Okay, sir. Thank you.
Then, kanida yon ang prelim exam. Kita ninyo ang display sa prelim?
Yes, sir.
Yes, sir.
Okay, so sa prelim exam ninyo, no, is consist siya of 3 items. Then ako i-attach na table para sa inyong basis para sa mga values inyong kuhaan para sa problem solving. So, 3 items, napod siya yung mga sub-items pod nga sulod kada item. So, answer directly na taan ni guys ha. Then 2 decimal places atong gamiton for calculations and final answer. So, handwritten niya po ni ha. Di ko gusto makakita ko ga-encode. Then, tapos, ang file name ani, prelim, last name, and section. Akong i-chat sa chat box. Inga na ang file name para aning aning prelim exam. So, ang deadline ani is on sa taron 6 no. April 8, 9 p.m. So sa U-step ya po ni siya ipasa, ako ni siya i-post karong gabi. So naba tay mga questions sa about sa prelim exam nato?
Ang kwan, sir, ang deadline.
Unsa to Joey, medyo hinay imong tingog.
Ang sa kwan, sir, ang deadline niya, sir.
Hinay gid imong tingog Joey. Ay pwede nimo ma-chat.
Ang deadline daw, sir.
April 8, 9 p.m.
Deadline daw, sir, sa
Lagi, deadline lagi ani. Prelim exam April 8, 9 p.m.
okay, sir. Okay.
9 p.m. Deadline sa prelim. Unsa pa yung mga questions nato with regard sa prelim and sa quiz number 3?
Wala man nata, sir. Na ano na po, na note na ang deadline, everything.
Okay, so hopefully wala mag-late submission ha. Wala exempted aning prelim. Ang quiz number 3 ray na exemption katora mga reporters. Okay, so kung wala reminders lang po no. Schedule sa atong midterm exam is on April 8, 1:30 to 4:30 p.m. So sa U-step ra nako i-post ang file din dito ra pod mo mag-submit. Please lang naka PDF lang pod ang atong file sa atong midterm nga exam. So I guess maura siguro to no. So kung wala na
Sir.
tayong mga questions.
Sir, na ako'y ano ba concern regarding ato bitang score sa assignment 2, dili ba daw consider tong mga scores bitang nga gamay kay ang units nila something like naa sa table or oo mao to siya sir nga concerns.
Assignment 2 or assignment 1?
Ay okay basta katong over 72
Assignment 1,
million.
sir. Assignment 1
Ah,
sir, 1.
Oo po.
Akong i-recheck tong mga naay mga unit sa taas kay daghan kaayo gyud ang nagbutang rag unit sa taas.
Oo,
Kaya ako
sir,
ang
nara
gina-
sa taas sa table.
Ako magong gina-check nara dito sa table and solution. So wala ko nagtan-aw sa taas. Sige lang kay kung correct ninyo ang mga values then na unit sa taas, di ako ra tong pang-usabon inyong mga score.
Sir, thank you, sir.
Oo, sa paman wala na no.
I think wala na sir, if ever is mag-chat na lang directly sa imo ha.
Sige. So kung wala na no, so pwede na ta mag-dismiss para makapanihapon na ta, para makapahulay sad mo kay gikan ra mo nag-exam daw, matud pa ni Kim.
Oo sir.
Sige. So class dismiss na ta. So goodbye sa inyong tanan. Thank you sa pag-attend.
Bye, sir.
Bye,
Thank you, sir.
sir. Thank you.
Goodbye, sir.
Bye, sir.